Sure. Comes on everyone. Let's start off. Hope everyone has tried the homework problems. Let's see. The first one is actually easy. This is theta. So this is before collision. After collision, the bullet gets embedded and the whole thing is going with some v common velocity. This is theta here. So this would be u cos theta and this would be u sin theta. This is after collision. So if you see, there are no horizontal forces here. So horizontal momentum is conserved. So that would be mu sin theta is equal to m plus m v common. So v common would be mu sin theta by m plus. This was kind of fine. This is straightforward, easy stuff. Just conserve horizontal momentum and you're done. Check.
So the normal is impulsive in this case.
Normal is impulsive, but that's the reason we are not doing anything in vertical.
Yeah, got it.
Clear, everyone? Now the second part. Looks like I think some of them went to IIT Bombay, I guess. Right now, cultural festival is going on, right? Why do you go to cultural festival? Next week there's a tech fest. I don't know, maybe what is there? Is there some rock show or something? Is there today?
That was the yesterday.
Okay. तो वही बोला सबको यार, you want to go for cultural festival ना, go once you go to IIT. Right now to go for tech fest. No, see.
Didn't go. I saw it on that page.
You can just go for one day actually next week sometime. Now look at this thing. During collision, if you look at the forces involved, the normal reaction is impulsive. Friction is also impulsive. If there are impulsive forces, you can't conserve momentum. And after collision gets over, the bullet gets embedded. And this goes with some v common. This is just after collision. Now, problem here, you can't conserve momentum in any direction, right? So listen, this is how we do this thing. So impulse problems are kind of different. Palaksh, your cam is not on, right? Do switch it on. So first thing, in the vertical direction, now what we are using is actually Newton's second law, more of a raw form. So this is what we are going to do. Integral f dt is change in momentum. So in vertical direction, the force would be integral n dt. Now don't worry about that integration. We're not going to integrate. This would be vertical momentum. So P final minus P initial. The final vertical momentum is 0. This will be minus of minus mu cos theta. I don't know n, I don't know dt, but I know what is integral n dt. Same thing in the horizontal direction, minus friction is backward, so minus F is equal to change in horizontal momentum in the horizontal direction. That would be M plus MVC minus MU sine theta. But I know friction is nothing but mu into N dt. And I know N dt is minus mu cos theta. So from here we get VC is equal to mu sine theta minus mu cos theta by M plus N. This would be the velocity. Now this is right. This is valid as long as VC is greater than or equal to 0. That is, sine theta minus mu cos theta should be greater than or equal to 0. That means mu should be less than or equal to tan theta. As long as the coefficient of friction is less than tan theta, this is right. Let's see what happens if mu is greater than tan theta. Please have a look at this. This is what I was saying. This does not belong to that algo which we discussed about. Meaning this actually belongs to the force category, but you're not using F is equal to MA. We're using something even more fundamental. F is dp by dt. The end of that, I'm still using second law, but I'm using its more raw form actually. That force into time ka integral is change in momentum. So we can't conserve momentum, so I'm using impulses in horizontal and vertical direction. And remember here, the problem is we assumed F is max here. We will talk about that in the next page. But do have a look at this. This is how you handle this problem. Clear till here? Now, what happens if mu is the problem here is if Vx is less than 0, there is a problem with this. Can Vx be less than 0? Can Vx be negative? I mean, the Vc, can it be negative? Think about it. Does it even make sense? The bullet is hitting this way and you're saying block is going backward. That's a blunder. So something definitely went wrong here. If Vc less than 0, meaning you are assuming the Fs becomes so strong, it is able to push the block backward. But tell me one thing, what is the job of friction? Is it to give maximum force? Its job is to make sure there's no slipping. That means if Vx less than 0 implies the friction never reached its maximum value. Meaning the friction was so strong, the block never moved only in the first place. The friction never reached max value. That is, friction is less than mu into N. So this equation actually becomes wrong. You can't write this thing. This would have been a wrong term. So you don't know F is equal to mu N. You can't assume it to be maximum. So therefore, the block never slipped. Therefore, Vc is equal to 0. So if you got Vc is less than 0, it implies the body never moved. So Vc is 0. You can't have negative. So therefore, your final answer Vc would be mu sine theta minus mu cos theta by M plus N. This is valid as long as the friction is less than tan theta. If you remember, that's actually angle of repose. And for mu greater than tan theta, the block is at rest. So if the friction value is very high, The friction is so strong, it will not let the block even slide in the first place. Just think of this in extreme case where, if the bullet is almost hitting like this, almost vertical, do you think the block will slide? Won't it just get hit and stuck? That way. That is one thing you have to be careful. You can't take VC negative here. Please check the steps. This is how you handle impulse problem. We're going to see something like this again, one more in collisions. And again, you will see something like this in rotation. Impulse problems are a different category only.
So, what happens when you like throw a basketball on the ground and it comes back to you then?
What happens? You catch it, right? No?
But like the velocity becomes negative, na? Like it's coming back to you.
Okay, so, but where is friction there?
The friction.
That is normal reaction, na God. Arey, N is acting up with. So if you push it this way, don't go back. Na kya problem hai N ke saath?
No, sir. Like you're standing.
Did you ever see a basketball like this? You throw like this and the ball comes to you like this.
Yeah. So that happens. If you
that is with a spin.
Yeah,
that is with a spin. Where is the spin here?
All right.
We will talk about that also in rotation. You're bringing completely different chapter now.
Okay.
Clear? That's a different question only. That so we will keep a ball with omega and we'll hit the wall with this. It'll hit and it'll bounce like this.
Sure.
Then they have to find the range. Hey, that is the last question in rotational mechanics. You directly went to the boss monster. First, you have to defeat single monsters. Clear? That is there. Next thing. Now, collisions. There are two types of collisions. The first one is head-on. So in head-on, the velocities of the bodies are along the common normal. The collision is said to be head-on. So for example, so these are the two spheres. This is your common normal. So if the velocities are like this u1 and u2, so this is a head-on collision. Suppose if you have an incline like this is a common normal. Velocity is like this. So these all are head-on collisions. In oblique collision, the velocities are not along the common normal. That is theta 1. This is going u2, theta 2. Or let's say the ball is hitting like this at an angle and bouncing off like this. So these are the examples of an oblique collision. The velocity is not along the common normal. Just to give an example, during caroms, right? If you have a coin here and if you have this striker here, remember we say sure shot coin. The sure shot coin is a head-on. Or suppose if you're good at caroms, you must have seen this thing, cut shot. You hit like this, coin goes like this, and the striker goes off like this. Cut shots are oblique. Same thing. You have done the same with the billiards also. So when you're playing carom boards, cut shots are all oblique collisions, and short shot coins are all head-on collisions. That's an easy way to grasp it. Caroms is like a pretty popular game in hostels, indoor games. There are many experts. They use all these collisions and solve.
Can you explain
College.
cut shot wala again?
You never played carom board?
It's a long time.
That's the problem. You should play enough games to learn physics. So it's like this now. The coin is here. Instead of hitting straight, you just hit it thoda angle pe.
Acha, okay, then understood.
And this thing goes away like this. The striker will go away like this. This
I
split
didn't understand how it moved. Okay, understood.
there. The moment is a cut shot, you should know if you're a caroms player. So hostels are used to a lot of competitions. People used to be scared of me when I used to play because when I hit the coins used to fly out of the carom board. So my game used to be different. How many coins will fly out of the board? The people used to be scared of me. They used to feel like, what the hell are you doing, Garike? I used to call myself the destroyer. So tha game. So in our group, na, there used to be one guy, Harish Karke. Very strong player. Matlab, this guy was pro level tha. He was too strong. So every time he and I used to be in the same team, right? To balance the things. So Harish ka common dialogue tha. It feels like I'm playing 1-on-3. If you understood. Means he used to feel, Arun, what the hell are you doing? वो हमारा coin नहीं है. I used to just put every comes coin. I said like क्या फर्क पड़ता है? For that poor guy used to play something and make sure to put a setup. I just used to come and hit right and left and everything used to be go for a toss. So I used to tell him it's a strategy, before confusing your enemies, confuse your friends. It used to be fun. There. That is a oblique collision. It used to be a fun activity. After dinner gets over, we used to sit for an hour, 1.5 hours. We used to do all nonsense. He used to ask me, Arun, why do you play like that? I said, I'm that chaos theory. If everything is normal, right, I'm the balancer, Thanos. Something of that sort. Great. So that's a head-on collision. Now, before going ahead with the collisions, right, there is one thing we need to discuss about materials. We'll see what actually happens during a collision. So, when we talk about materials, in reality, there are actually two types of materials we have. One is called plastic materials. Again, plastic means is not your Cherka plastic. We have a very, we misuse a lot of words actually. They mean something. Scientific word meaning is something else. Practically, we mean something else. Plastic materials are when forces are applied, the body deforms. And it does not recover at all when force is removed. Best example is your chapati ka dough. You push it, it will deform. You remove the force, it will still remain in the same shape. So if you take some chapati ka dough kind of thing, and if you try to apply force F, this is what it becomes. It gets deformed. Now, if you remove the force, the shape is still there. Force is removed, but the deformation still exists. There is no recovery at all. These kind of materials, right, are called plastic materials. These things do not generate any internal forces to restore. The second type of materials are called elastic materials. So these materials, they deform when force is applied. right? And when force is removed, they recover completely. So if you have a body here, you apply force. This is going to deform. And when you remove the force, it comes back to normal. Then what is a rigid body then? Then what's a rigid body?
It doesn't deform again.
First of all, deform ही नहीं होगा. They're hypothetical. The rigid body, right? First of all, they don't deform only. No deformation, independent of force. No matter how much force you apply, they don't deform. So you need to understand elastic materials, right? It's not like they don't deform or they don't get bent or anything. They do deform, but they recover back completely. It is like, think of a situation like this. You know, when you go to a temple, right? This is a mistake most people do. You go to a temple or you go to any place and you pray to the God, like, and it's like, God, make sure I don't have problems in life. Right? God will never grant you that because it's not possible. Right? So the thing is, people are asking it wrong. You should be asking, like, God, give me enough strength to make sure I can recover from any problem in life. Both means a lot of different things. Right? In the first, what we expected as humans, we think like, problem ही नहीं होना चाहिए. But it's the other way around. Problems to hoga hi. You can't avoid them. So what you need to do is you need to become strong to overcome. So rigid body is the ideal case where there is no deformation only. Elastic material is that case where it says, chalo, I will get deformed, but I will recover and get back to normal state. Getting the difference? The plastic material is like a lazy friend. If there is a problem, he says, he doesn't even know there is a problem. He's chilled out, least bothered. Plastic and elastic are the same. Plastic is like an extreme case where there's no recovery. Inelastic meaning there's some recovery. Clear? But in nature, right, most of the materials are between plastic and elastic. Clear with this? That way. It's important you should have some inconveniences and problems in life, or else you'll never grow strong. Now, look at this thing. So analysis of a collision. What happens exactly during a collision? Listen to this carefully, quite important. There are few things, right? We can actually play around with that. We're going to analyze for head-on collisions. If you know how to do head-on collisions, oblique collisions are easy. So let's say we have two balls here, mass M1, M2, going with U1, going with U2. U1 is greater than U2, obviously, meaning it has to go from the back and collide. So the moment they collide, the bodies will start deforming. The speeds will start changing V1 and V2. So there's a normal reaction in and there's a normal reaction in. So here V1 is decreasing, V2 is increasing, but remember V1 is still greater than V2. So here the deformation between them is behaving like spring. So as this collision is going on, at one point, the body will have maximum deformation. So V1, V2, at this point, V1 becomes equal to V2. This is just like that spring thing which we did last time, if you remember. Maximum compression in the spring. Now, at this point, now what happens will depend on the type of the material. Now the material will have three choices. The first option, if the materials are made of plastic materials, this is called a perfectly inelastic collision. So what will happen? The two bodies, right? Remember what happens if they're plastic materials? Once they deform, they don't recover, right? So they will stick together and they'll go with a common velocity. They move with common velocity and there is a maximum deformation. There's a maximum loss of energy. There is a max loss of energy. This is also called as E is equal to 0. We'll see what is E later on. The second option, the bodies will deform, but some deformation is left. Like a car goes and hits a pole, there's a dent. So V2 becomes greater than V1. They separate, but there is some deformation. There is some loss of energy. There's a third option. They completely recover. V2 is greater than V1 and there is no loss of energy. So basically this is E is equal to 1 and this is perfectly elastic. Now, no matter which collision it is, this process is same. What happens after this will depend on the type of the material. If you're dealing with plastic materials, this is the scenario. If you're dealing with perfectly elastic materials, this is the scenario. Somewhere in the middle, this is the scenario. Please check this page. So this is what happens during a collision. So this process is important. Clear? Arjun, Aditya, clear with this? Swastika, Abhinav,
Yes,
Vidyut, Ali. Next thing. So in all these collisions, right, the common thing is, so when you solve collisions, you actually have two concepts. One, conservation of linear momentum, because that during collision, the forces are internal.
So can you go to
M1.
the previous slide once?
M1 U1 bar, M2 U2 bar is M1 V1 bar plus M2 V2 bar. Momentum conservation. The second thing, we have something called E, which is coefficient of restitution. So restitution, it's a Latin word. What it means is, it tells us how much energy is recovered from collision, from deformation. So E is equal to 1, meaning complete recovery. E is equal to 0 implies there is no recovery. So this E is given by V2 bar minus V1 bar by U1 bar minus UT bar का module. So this is relative velocity of separation along the normal. This is important. You should take the velocities always along the common normal. These are not complete velocities. Relative velocity of approach, that is the initial relative velocity along the common normal. There. So all collisions, right? We can solve using these two concepts here. Have a look at this. Clear? Let's see some questions on this. Let's say we have a sphere of mass m, speed u. So let me show you one. This is mass m. This is at rest, and let's say E is equal to half. So when you solve these problems, step one, draw the final diagram. So 2m v1 v2. Step two, conserve linear momentum. Step three, use restitution. That's it. So when you conserve momentum, you end up with 2mu. Initially, that is 2mv1 plus mv2. We get 2u is equal to 2v1 plus v2. Restitution E is equal to v2 minus v1. Now, so here you're choosing this as 2, so u2 is 0 and this is u1. By u1 is u minus 0 is half. So v2 minus v1 is u by 2. Take v2 from here and substitute in this equation. 2u is v1 plus u by 2. So you end up with v1 is equal to u u by 2. And v2 is equal to u. That means after collision, the 2m is going with half of the speed, and whereas this m guy is going with speed u. Vectors narrators. There's no concept of vector division. Isn't it? v2 minus v1 bar 1, v1 minus u2 bar. You can't take vector divisions there. Clear? Steps are easy. Draw the final diagram, conserve momentum, restitution, and you're done. Check it out. Clear? Turn the page. Now you guys try the same thing. Mass m, speed u, mass m. It is at rest. Restitution is e only. So give me the answer in terms of e. Find final velocities. Hmm. You add equation 1 plus 2. V1 gets cancelled. You end up with V2 is equal to U into 1 plus E by 2. V1 will be U by 2 into 1 minus C. Yeah. So here we get a good result. If two bodies of same mass collide, elastically, they exchange velocities. Now here this is important. Most people remember only this part, exchange velocities. The next word is more important, along the common normal. Head on में तो problem नहीं आएगा, but oblique में will have that issue. They don't exchange their full velocities. They exchange components only along the normal. Meaning, suppose if you have mass m traveling with speed u1, and if you have mass m traveling with speed u2, this is before collision. After collision, this m will go with u2, and this m will go with u1. It feels that both of them exchange velocities, including direction. T should be 1 and masses should be same. Sure, must have seen something like this. So see there, so you're leaving 1. So what's happening, right? The left one is hitting the second one. First one stops, second moves. Second hits the third, second stops, third moves. This is happening so fast, there is a very small distance. It feels the last one is directly flying off. I'm sure you must have seen this in movies, the villain ka room mein ek hoga and he's making some evil plans. This thing is going on. Now, what if I put two balls? Two will fly. What if you keep three? Now, see what is happening. When you're keeping three, only two are there on the other side. So two will fly, third one goes off. The middle one is always swinging.
So this is Newton's cradle now.
This is called Newton's cradle. Look at this thing, 3 and 2. Here you can see more clearly. Now see, they removed the middle one. Here you can see more clearly. See, you remove the middle one and now you make them collide. There. This is what is actually happening. That comes, it's the second one, second goes and it's that fourth one goes and it's the fifth one. There you can clearly see more clearly now in slow motion. So that's how it goes. So if you have two bodies of same mass, then they collide, they exchange velocities. Clear? Let's see a question on this. GM, M, M, and N. This is going with you. E is equal to 1 for all collisions. Find the final velocities. Final velocities meaning after all collisions, these four balls ka velocities. Initially, these three are at rest. Try, I'll give 3 minutes. It's a good one. Involves little working, but yeah. Any guesses how many collisions are there? Nahi, Anika, that is wrong. How many collisions are there?
Definitely more than 3.
ये definitely more than 3 किया. So if I ask you tomorrow कितना J rank आएगा, definitely more than 10,000. See, you don't like that answer. I mean, definitely less than 10,000. 5, nahi, Aryan. Any other guesses? I think Anusha is right.
So
Ali,
sir,
you are right. Type your answers, type your answers. We have 2 right answers. Anyone else? Right, Abhinav. Infinity nahi hai, God. Chalo, theek hai na, solve. Do one thing. First, can you find the velocity after the collision between these two? First, find that. From there, we'll see. Get that, I'll give you a minute. Find the velocity of 3m and m when these two collide. I'm sure you must have done that already. So if you do only for 3m and m, this is traveling with you. This is at rest. So after collision, this is v1. This is v2. Conservation of momentum. 3mu is equal to 3mv1 plus mv2. And E is equal to v2 minus v1 by u is equal to 1. So v2 minus v1 is equal to u. This is the second equation. You end up with v1 will be u by 2. v2 will be 3u by 2. Got the same? So
Yeah.
let's try to understand this, okay? The meaning of this is, after every collision, the speed of 3m becomes half. This m ka speed becomes 3 by 2. Try to remember that way. So whenever 3m collides with m at rest, the speed becomes half. Now, because the end of that it's a variable, right? In place of u, if I keep u by 2, then end mein u ka place mein u by 2 aayega. It becomes u by 4. Whatever was the initial velocity, it becomes half of that. That is the meaning of it. Now, once you understand that, that's it. There's no need to solve multiple times now. Now see what happens. Now we just need to trace the whole thing. 3m, m, m, m. This guy is going with you. This is the first collision. 3 and m. This is the first collision. So after the first collision, 3m is traveling with u by 2. 3m didn't stop. This guy will go with 3u by 2. Now, this is a second collision. Now, actually, all this will happen instantaneously, but let's split it slowly. 3m is still traveling with u by 2. This m will come to rest. This m will gain velocity. So it will exchange velocities. This is a third collision. This is still going with u by 2. This came to rest. This came to rest, and this guy is gone with 3u by 2. Now again, these two will collide. The fourth collision. Right, Lakshika. Now remember, just now I said whenever 3m collides, its speed becomes half. So u by 2 becomes u by 4. And this guy will become 3u by 4. So that is how, instead of solving every time, if you can understand that u is simply a variable, and you will see it forms a sequence. Every time it becomes half of the previous one. This guy is at rest in the middle. This guy is going with 3u by 2. These two will collide. This is the fifth. This guy will come to rest. This will go with 3u by 4. And this will go 3u by 2. Now 3u by 2 is greater than 3u by 4. So there is no collision between these two. It is done. Now again, these two will collide. This is the sixth collision and the last collision. Again, the speed becomes half. So u by 8. This guy becomes 3u by 8. This guy becomes 3u by 4. This guy becomes 3u by 2. And you're done. They'll not collide after this. Check it out. In total, it will be 6 collisions like this. So the main idea, most of you, what you forgot, right? You forgot that 3m will come and again collide with m. The 3m is not stopping. So it just keeps coming and hitting non-stop one after another. Finally, the speeds will become in such an order, so they will not collide again. Please have a look at this page. Clear, everyone? Make sense? Easy? Just have to solve once. After that, you can just keep saying it becomes half. So can you tell me what happens if there are like 3m and there are like 10 balls? What is the final velocity of this guy?
U by 2 to the power 10.
So if there are 3 balls here, you observed it became u by 2 cube. This guy will become u by 2 to the power of n. This guy will become 3u by 2 power n. This guy will become 3 by 2 power n minus 1. This guy will become 3u by 2 power n minus 2 and so on. Get in the sequence? We can play like that. This guy will be 3u by 2. So yeah. If there are 10 balls, so then n balls, so this is the sequence. So n you can put 10 and finish it off. So you can do this even for multiple things. Right, Lakshya? You got that. Then
So
next
the
thing.
last ball will have the max velocity.
Yeah,
Okay.
let's say another easy one. We have a pendulum, 2m, with the string of length L. Another ball of mass m going with speed u, and let's say e is equal to half. Find u if the pendulum completes a vertical circle. So after collision, the pendulum should complete a vertical circle. Vertical circular motion and collision. Last page here. General formula, I erased it. Right? Want to write it? Kya? Oh, problem kya na? It is only for 3m and m. If mass is something else, the ratio won't be same, no? So 3m, m, and so on. N balls. This would be u by 2 power n. This will be 3u by 2 power n minus 1. 3u by 2 power n minus 2. So on. This guy will be 3u by 2. Okay? It'll be there, don't worry. But like I said, it's only for 3m and m, so that is the reason I don't like it. We can actually take m1 and m mass and we can actually get a general formula. But he can. You can remember something, like I said, see, you can remember a formula if it is going to come multiple times. Just one special case, there's no point. Then physics will start looking boring actually. Then it becomes like chemistry only, mugging up everything. Get this thing. Easy one. After this, we'll do some deadly ones. Two root GR. Okay. 2 root GR. No, that is definitely wrong there. Vertical circular motion, God. 5. Maybe. Let's see. Others? Any other answers? We have one answer. Not sure though. See. So the main data here is the velocity is given after the collision. So after collision, let this guy be V1, let this guy be V2, and this thing is at least root 5GL, isn't it? Hope you remember the result. If it is a rod, what is the result? What is the rod result? Anyone? Vertical circular motion for a rod, minimum velocity, root 4GL. What is the difference in tension between the upper point and the lowest point? Tension. The difference in 6 mg, right? Right, Anusha. Do remember the standard results. So mu is mv1. The reason I call it standard is because CET bits, J mains, they ask direct questions like that. You won't have time to solve each and everything there. Restitution E is equal to V2 minus V1 by U is equal to half. So if you look at here, the one I don't want here is V1. The eliminate V1 here. The U is equal to V1 will be V2 minus U by 2 plus 2V2. 3U by 2 is equal to 3V2. U is equal to 2V2. So that is root 5GL, right? Yeah, right, actually. Check this out. Right, Aryan, Aditya, Arjun. Yeah. Easy one. Check it out.
So
Hmm.
if we held this string like at an angle and then send the ball horizontally,
Then root 5GL nahi hoga na.
but like wouldn't this string snap because the intention would become impulsive?
No, don't break the string, na. It will become impulsive. You hit like this, then you take momentum in this direction, na.
Okay.
Perpendicular to tension.
Got it.
Clear with this, everyone? Next one. Let's say we have 2m, 3m, let's say 2m. This is traveling with you. काम करते wait. Let this be 2m, let this be m, and let this travel with u. And let this travel with 2u. And E is equal to 1. Okay? So find max deformation energy. I want to ask you a question, theoretical question. Listen to this question. In a perfectly elastic collision, kinetic energy is constant. True or false? Why?
Wait, so you said perfectly elastic?
In a perfectly elastic collision, E is equal to 1. Kinetic energy is conserved. Go back to the process in the collision. See what is happening. When this collision is happening, some of the energy is getting stored in the form of deformation. You're getting it? Then again it recovers. So the kinetic energy initial, the kinetic energy final are equal. Kinetic energy is not constant. Are you getting it? So most people are goof up this part actually, because exam there'll be statement question like this. In a perfectly elastic collision, kinetic energy is conserved. Blunder it is. Initial kinetic energy is equal to final kinetic energy, but kinetic energy is not constant throughout the process. Are you getting the difference? It's like you had, you had 100 rupees, right? I took 50 rupees from you and I gave back you 50 rupees. So finally, initially you have same money, but it doesn't mean you have 100 rupees throughout the motion. some of the energy goes into the deformation and then comes back. So kinetic energy is not constant throughout the process. Initial and final are equal. So approximately plot kinetic energy versus time graph. Meaning they'll give you 4 graphs and ask you to choose an option. Plot kinetic energy of the system versus time graph. Approximately. मतलब roughly कैसे दिखेगा? Get these two. So remember that thing. Just because E is equal to 1 doesn't mean, kinetic energy will be constant. They always talk about initial and final. What happens in the middle? It always deforms. mu square. I don't know the answer. देखना पड़ेगा. Let's see. Others try. I'll give a minute more. These are the kind of questions, right? If you don't know what is happening in a collision, you can't solve. The regular ones are fine. E de diya, find velocities. Those are standard ones. You can get, the questions can come based on that basic concept, like what is happening in a collision. That's it. Again, if you go back to the process, 2m, u, m, u, the maximum deformation occurs in this state when the bodies are maximum deformed. They're going with a common velocity. वो catch था. Getting it? Finally, they will open up. That's okay. I'm not interested in that here. V1 and V2. So here, the deformation energy is maximum deformation energy is here. So if you conserve momentum, 2mu minus mu is 3m Vc. So Vc 2m 2u na. That would be V. U are actually. Vc is u. Then if you take here state 1 and state 2, the energy in state 1 is equal to energy in state 2. Here it will be kinetic energy of 2m 2u whole square plus half mu square of 3m v common square plus max deformation energy. So if you include the deformation energy, you can say the total energy is constant. This guy would be how much? 4 of 9 by 2 mu square. This is 3 mu square by 2. So this is max deformation energy. That would be 9 minus 3, 6 by 2, 3 mu square. And there's a much faster way to do this thing. If you can think of like this whole question looks like this: 2m and m. This is 2u. This is u. What I'm asking indirectly is maximum deformation. Because see, the mathematics doesn't care whether it is a collision or whether it is a spring, isn't it? And if you remember the result, what was this? Half k x max square is half mu reduced mass v relative square. This is your maximum compression energy, isn't it? This is your max deformation. And here the reduced mass will be 2m into m by 2m plus m, and v relative will be 3u whole square. This thing turns out to be 3mu square. Check. Remember this thing in the 2 blocks in the spring. You can actually use the reduced mass thing and finish it off. Half reduced mass v relative square will give you the deformation energy, max deformation energy. Because max doesn't care whether you're talking about a deformation due to a spring or deformation due to a collision. The equations look identical for it. This is one best thing you need to know. As long as the mathematical equations look same, it doesn't matter which chapter it is. This is your maximum deformation energy, and from here you can also find minimum kinetic energy. So at this position, you also have minimum kinetic energy. So kinetic energy goes to a minimum value here, which is total energy. How much is that? Total energy is 9mu square by 2 minus 3mu square. That would be 9, 8, 6, so 3mu square by 2. This is your minimum kinetic energy. So if you try to plot the graph, the kinetic energy versus time, again, approximate graph, the value, so once the collision starts, the kinetic energy will decrease and again become constant. This is 9mu square by 2, the total value. Kinetic energy will reach a minimum value here, 3mu square by 2. This is minimum kinetic energy or maximum deformation energy. So the graph should go down and then increase back to the initial value. So keep this in mind. Kinetic energy is not conserved in perfectly elastic collision. Final is equal to initial, but conserved meaning it should be constant everywhere. I can say kinetic energy is not constant. But Ke initial is equal to Ke final. Just because initial and final is same doesn't mean you're constant. Check this out. All clear with this? Anyone not clear with this? Swastika, clear with this? Yasha? Vartika? Clear, no? Aryan? Anika? Utsa? Clear with this? Can I go ahead? Abhinav, go ahead.
Yes, sir.
Sir, can you just wait a moment? I'm writing it down.
You'll get the notes, right? Don't worry about that. Just put on the main things. Focus always on solving and understanding. Don't worry about the notes. You'll get the PDF anyways. And where will you write anyway and publish a book next year? Put it on, put it on. Important. Whatever you think is important, you can put it up. I know my handwriting is not that great. I do understand. My mom still scolds me. I said, you become a teacher and still your handwriting is bad. I said, my students don't have a problem. What is your issue, करके? So, moms are moms. Next one, sir. Let's say we have a 4 kg body here going with 3 meter per second. Let's say this is 2 kg. This is at rest. So here F is the force due to collision on 2 kg block. Hmm, So if you try to plot the graph, again hypothetical graph. Let's say this time is 4 into 10 power minus 3 seconds. Hmm, 6, 9, 2. One second, let me calculate some values or else things will go bad. I hope so. 3000 newtons. So a force is of 3000 newtons acts for very small time, 4 into 10 power minus 3 seconds. So this F is the force due to collision, force on 2 kg block during collision. Let's call this thing sometime T naught. The first one, find coefficient of restitution. Find T naught. T naught is the time when the force reaches peak value. Indirectly, he's saying it's maximum deformation. That you need to figure out though. So both these balls are in contact for this much time. 400 mm, meaning collision gets completed in this much time. Find max deformation energy. That is also fine. Sure, let's get this. Hope the question was clear. Anyone not clear with the question, please ask me. Time is 4 into 4 by 3. Okay. Might be. I don't know the answers. So first find D. देखते हैं. These are the kind of problems you should be more thorough with. The regular problems you'll be able to handle. If you really don't know what is happening during a collision, that process, you'll have difficulties in understanding this deformation and all this stuff. See, what is area under FT graph?
Change in momentum.
Change in momentum. So indirectly, you got the change in momentum. I hope I didn't give the wrong values. So area under FT graph will give you change in momentum. So impulse basically that is half into 3000 into 4 into 10 power minus 3, that is 6. So on 4 kg block, the force will be backward. On the 2 kg, the force will be forward. So this change in momentum, so let's call this thing basically impulse. So on the 4 kg block, impulse will be minus 6. Is the change in momentum of this. So let the velocity be v1, let the velocity be v2. So 4 into v1 minus 4 into 3. So we get 4 v1 is equal to 6, v1 is equal to 3 by 2. On 2 kg, impulse is forward, so it will be plus 6. That will be 2 into v2, and initially it is at rest, so v2 is equal to 3. Getting it?
But it's not the change in momentum for the whole system.
Whole system क्यों होगा? What is F? Force is on what?
Acha, on 2 kg. Okay, missed that.
If you take the total force, 0 होगा ना record?
Hmm.
ना? तो v2 v1 आ गया. Now restitution E is equal to v2 minus v1 by u1 minus u2. v2 is 3, this is 3 by 2, and u1 is 3. So half. Right, Aryan? So that is how you find the velocities. Whatever force acts on 2 kg, the same force will act on 4 kg, but in the opposite direction. So 4 kg will lose that momentum, 2 kg will gain that momentum. That's why 4 kg के लिए minus and 2 kg के लिए plus 6. There, once you got the velocity, the first part is done. Now we need to find the T naught. Max deformation energy is easy. We can just use that formula, just now I taught you. Half mu relative V relative, half mu B relative square. That तो one step में answer आ जाएगा, max deformation energy. For max deformation energy, you don't need to care about restitution. All that is, you don't require anything. Time T naught is the fun part. Try, I'll give another minute. How do you go to T naught from here? I gave you this big hint also, no? T naught is the time when the force is maximum deformation basically. Because when the compression is maximum, the force will be maximum. See, 4 kg, 3 meter per second, 2 kg, this is at rest. So at max deformation, both are going with a common velocity. That means 4 into 3 is equal to 426 Vc. So V common is equal to 2 meter per second. That means for 2 kg block, the change in momentum will be mv final will be 2 into Vc, na? That is 2 into 2, 4. So that means till the time the common velocity is acquired, this is the point of max deformation. Meaning this area is the change in momentum of 2 kg block, isn't it? Whatever is the area under the graph up to this point will give you the change in momentum up to this T naught. This is T naught and this is 3000. So this area is change in momentum of 2 kg block up to maximum deformation. What is that area there? So that area would be, so change in momentum, that area would be half into base into height is 3000 and this is 4. So T naught will be 8 by 3 into 10 power minus 3 seconds. Is that making sense? You find the velocity of the 2 kg at maximum deformation, which is a common velocity. Finally, the 2 kg velocity will be different. I'm not interested in that final situation. Finally, the speed is 3. Means up to this point, maximum deformation, it will acquire speed 2, and while opening up, it will acquire 1 more meter per second. So they can even ask a question like this thing, find the ratio of time the body is compressing and the ratio of time the body is expanding to natural state. That also would be a good question. That will be the ratio of this time interval ka difference. So you can play around with all those kind of time ke questions also in this. And इसमें तो max deformation energy is easy. Just use half mu v relative square. V relative is initial velocity, so half 4 into 2 by 4 plus 2 v relative is 3 square. I'll leave the working day. Check out the time is a good one. If it's a paragraph question, I'll ask you these two only. Find the restitution and find the time. Or even better, find the ratio of time the body is compressing and the ratio of the time in the body is expanding to natural state.
Can you show the question to answer? Thank you,
Again,
sir.
hypothetical graph, but please check everyone. Ask me if you're confused. So basically, at max deformation, they have common velocity. Clear with this? Next one. Any doubts on this? P is FT. P is FT. What is P and what is FT, Ransha? What is F into T? It is integral f dt, God. F constant नहीं है. Next one. We have a wall here which moves with a constant speed u. The wall is moving with constant speed v. Restitution is e. So the ball is coming with speed u and hits the wall. Find the velocity of the ball after collision. Now, one thing in these kind of questions, now keep this one thing in mind. During a collision, the velocity should definitely change. No matter how big the body is, velocity at least will change a small amount. But here you're saying the wall ka velocity is constant. During a collision, velocities change. No matter how big the body is, at least thoda to change hona chahiye. So here, an external force is required to maintain the wall ka velocity. So wall ka speed won't be constant just like that. Someone is pushing it from outside. And then they're not going to say that word. You need to figure it out. Required to maintain a constant velocity. That means there is some force acting on the wall which is not being discussed. Required to maintain a constant velocity. So remember, whenever you hear the word something is going with constant velocity, momentum is not conserved. A vehicle with a constant speed is hitting something. The moment you hear the constant velocity discussion closed, collision mein momentum conserved nahi hoga. Because during a collision, no matter how heavy the body is, velocity will change a bit. Momentum is not conserved. So keep that in mind. A wall with constant velocity, a vehicle with constant velocity, you will hear these kind of words. Momentum won't be conserved. That means, remember, in the collision, there are two steps, momentum and restitution. One part is gone. The only thing left is restitution. Try. I'll give you 2 minutes. Answers. Just start with restitution. One equation में answer आ जाएगा. Just be careful with the signs though. That yeah, Anusha, Lakshika, that looks right. Right, Aditya. खाली e का वैल्यू दिया नहीं. God, how did you get numbers? You took e is equal to 1. Sign mistake था वो. Minus u नहीं है. Try others. I'll give you a minute more. नहीं है Anika. See. So here the two systems are the wall and the ball. So choose something first of all. Decide who is 1 and who is 2. If I say this is 1 and this is 2, here u1 is u, u2 is minus v. The wall is going this way. After collision, let this guy go this way with v dash. The wall will continue with v. So V1 is minus V dash and V2 is minus V. That's it. If you're just careful with the signs, you get the answer. So E is equal to V2 minus V1 bar minus U1 bar minus U2 bar. Right is positive, left is negative. So V2 is minus V, minus of minus V dash by U1 is U minus of minus V. So we get V dash is equal to V plus E times U plus P. Or V dash is equal to EU plus V into 1 plus E. That's your general formula for a constant wall. If the wall was at rest, V ka term would be 0, then V dash would be EU. This is quite a useful one. So if you have a wall at rest, if you hit the wall with speed U, you'll bounce back with the speed of E times U. Keep that in mind, helps. Check it out. So when you hit a wall with U, you'll come back with EU if the wall is at rest. Wall is moving, then this is the more general formula. You can't, there's no need to conserve momentum. Only restitutions will get the answer. Because in this case, you know both V1 and V2. So you have data. Check it out. Clear? Got this? Next one. Utsa, clear na? Vidyut, Arjun, Aryan, Swastika, Anika, clear, right? Great. Next one. We have a ball projected with speed U. Restitution is E. So this guy goes up, comes down, hits the ground, again bounces, comes back, and so on. Find total distance, total time, and average speed. I can directly ask you average speed. Total distance by total time. So find total distance traveled, total time, and average speed. Get me the average speed. I hope you guys remember infinite GP ka formula. In case someone forgot, the sum of infinite terms, A, AR power 1, AR square. So until infinity, this is given by A by 1 minus R for R less than 1. Remember that. You will need that. Infinite geometric progression, sum of infinite terms. The answer will come in terms of E. U by 4 आया क्या? That I'm not expecting. हाँ. नहीं रे आदित्य. नहीं Yasha, that is definitely wrong. Achka, that might be right. Suppose, listen, if this question comes in the exam, कैसे guess करना है? How do you guess? Anyone? How do we guess?
You should have a 1 minus something in the denominator
Why?
because of the infinite GT thing.
Not necessary. Suppose if I keep E0, what will I get? Goes up, comes down and stops, na? So distance कितना आना चाहिए? 2 times h, right? So if you put E0, the formula should give me 2h for the distance traveled.
Yes, sir.
Average speed के लिए what will it give? 2 times h max u square by 2g and time of flight is 2u by g. I would have got u by 2. If e is equal to 0, the average speed would have been u by 2. I can check my answers. If e is equal to 1, the ball will never stop. Distance will be infinity. You getting it? So by putting values, you can check it out. But anyway, we can solve this. So when you project it with speed u, this guy goes up and comes down. So let this be h max. We know h is equal to u square by 2g. So height is proportional to u square. Time of flight is 2u by g, which is proportional to u. So if this time is t, the second time you hit the ground, the speed becomes e times u. So remember, every time the speed becomes e times, the height becomes e square h. Time becomes e times t. Now your speed is e square u. So it is e square ka square. So e power 4h and time is e square t. So this is how the sequence forms. The total distance will be, remember distance. So up and down, you have to count 2 times. I think Aditya forgot that. So 2h plus 2 times e square h plus 2 times e power 4h and so on till infinity. Take out 2h common, you end up with that sequence 1 plus e square e power 4. This will be 2h by 1 minus e square. There's if you put e0, I'm getting 2h. Minus sign nahi aayega re denominator mein. Total time, this will be t, et, e square t, so on till infinity. If you take out t common, you end up with a sequence 1 plus e square, so on till infinity. This would be t by 1 minus e. So the average speed would be 2h 1 minus e square by t by 1 minus e. That will be 2 into u square by 2g. This guy becomes 1 plus e, and this guy becomes 2u by g. U cancels off, you end up with u by 2 into 1 plus e. Check. If e is equal to 1, your time also will be infinity, have distance also will be infinity. So basically you're getting two large numbers. The ratio is constant. Distance will be infinity, time will be infinity. But when you divide them, you get a finite value. Average speed. Have a look at this. Clear? Vartika, clear with this? Udian? Clear, no? Turning the page. Anusha? Clear? Yasha? Got this? Perfect. We have a dumbbell here, mass m, 2m. So we have some fixed support here. We have some fixed support here. These are fixed. Here E is equal to half, and here let's say E is equal to 1/3. Restitution is not same. So these are connected by a massless rod of length L. And this dumbbell is dropped from a height h. So what will happen? They will fall straight, right? Rod will be straight only, na? And they'll go and hit the supports there. Now, because E is not the same, both of them will bounce back with different velocities. This will make the rod rotate. Find H max of center of mass after collision. Find angular velocity and tension in the rod just after collision. Find omega and tension just after collision. Just give me a minute. Find omega and tension just after collision. Diagram is clear. What happens? Dumbbell will fall straight. Once you hit these supports, both will not have same velocities. Now, because both don't have same velocity, the rod will start rotating. Better question would be find the coordinates of 2m as function of time t. But okay. Once you got omega, you'll be able to do that also. Try. It's a good one. I'll give you 4 minutes. Just get this thing. Let's see the answer. 4h by 21. Okay. Try others. H max is easy. H max 91, H 16H. Should try एक भी आंसर मैच नहीं हुआ किसी का. Let's see. I'll show you the H max part. So when they're about to hit, understand both are falling at the same height. So this velocity will be u, this also will be u, and u is equal to root 2gh. This is just before collision. The rod will remain horizontal. 5h by 18, not a single answer is matching for anyone. Let's see. So after collision, this 2m, this is m, this bounces with, remember, this is e is equal to half, e is equal to 1 by 3. So this guy bounces with u by 2, and this guy bounces with u by 3. The center of mass will be somewhere here at a distance of L by 3. So this is VCOM. So velocity of center of mass will be 2m u by 2 plus m u by 3 by total mass. Hope you guys did this. Dumbbell bend. Don't bend the dumbbell na रे God. ये सब क्यों करना है? Don't bend the dumbbell. Dumbbell will bend. Dumbbell will fly away. Someone will catch the dumbbell and sell it off. नहीं करते ऐसा चीज. Dumbbell will rotate. Dumbbell won't bend. So this would be mu plus, that is 4mu by 3 by 3m. 4u by 9. Because the dumbbell can't bend, it rotates. That is the whole concept there. Then you're done now. H max is what? V center of mass square by 2g. That would be 16u square by 2g into 81. 8u square by 81g. And u is what? U is 2gh. 16h by 81. Who got this? Lakshika, you got it. Utsa, you got it. Others goofed up. Check it out. Period went wrong. Check where the calculation went wrong. अभी तक question हुआ नहीं. Now find tension and omega. Tension is the actual question. So if it was an advanced question, I'll ask you find tension in the rod and coordinates as function of time t. That you can try for fun. The coordinates of m and 2m as function of time t. It would be like that first question. Remember, rod is rotating and translating. So ऐसा होगा. It's like this point is going in a center, and both these dumbbells will rotate about the center of mass. Omega is easy. Do you remember omega ka thing? Omega is what? Relative velocity. If 2 points are given, it's relative velocity perpendicular to the line joining them. We did this in circular motion. Line joining AB by distance between AB. A and B are the 2 points. So here omega would be u by 2 minus u by 3 by L, u by 6L. That's your omega. The tension might be right. Let's see. So now when you want to find the tension, this is 2m. This is m. This is center of mass. This guy is going in a line. So this is how the motion will be. The 2m is like this. M is like this. So this is how I think I might exaggerate it a bit, I guess. So this radius will be L by 3 and this is going in a circle of L by 3. This guy are L by 3 and this guy is going in another circle. So this is how you find coordinates. So that is a different thing. You just want to find the tension. So tension T, the centrifugal force will be 2m omega square, radius is L by 3. You got to take in this guy also. Tension T, this will be m omega square 2L by 3. Answer would be same. The tension will be 2m omega square L by 3. 2m omega is u by 6L. So u square by 36L square L by 3. mu square by 54L. Check. There, once you got omega, that's you get the tension.
So can you go to the playlist? Sir, in this, the balls are going in a circular motion with respect to the center of mass.
Right.
So shouldn't we take the distance from the center of mass?
Okay. How much is that?
L by 3, right?
So fine, but here I'm taking relative velocity between these 2 points, na? Then काम करो, then take relative velocity between these 2 points.
Okay, got.
Na? You want to take with center of mass, take, na? Then take relative velocity with respect to center of mass. Then you'll write u by 2 minus 4u by 9 by L by 3. See, omega is not about center of mass. It's like it is relative velocity between any 2 points by line joining them. That any 2 points can be center of mass also. Center of mass is a point about which you can split the motion into translation plus rotation. But fine, that works. Clear with this, everyone? Next thing. Oblique collisions. Now, like I said, if your head-on is good, oblique collisions are easy to manage. So in oblique collisions, what we do, step 1, draw the common normal just before the collision. And resolve the velocities along and perpendicular to the common normal. Second thing. Then, so for velocities along the common normal, just solve it like head-on. So velocities along the common normal will change because the force is in that direction. So just treat this like a head-on collision. And the velocity component of velocities perpendicular to the normal are unaffected. Then finally, add the perpendicular components to the final velocities. Let me show an example. Example. We have mass m1, mass m2. This is a common normal. This is going with u1, theta 1. This is going with u2, theta 2. So step 1, resolve the velocities along the normal and perpendicular to the normal. So this was the normal, this was the normal. So this would be u1 cos theta 1. This would be u2 cos theta 2. This would be u1 sin theta 1, and this would be u2 sin theta 2. So during collision, if you see, the force will be along the normal. So these things are unaffected. And this here looks like a head-on collision. And then you know how to solve head-on. So let the final velocities be v1, velocities be v2, conservation of momentum, m1 u1 cos theta 1 minus m2 u2 cos theta 2 is equal to m1 v1 plus m2 v2. Restitution is equal to v2 minus v1 by u1 cos theta 1 minus of minus will be plus u2 cos theta 2. Here you will get your v1 and v2. So the final answer will be, and remember these components are still there. So your final answer will be this m1 will have a velocity v1 this way and u1 sin theta 1 this way, where m2 will have v2 this way and u2 sin theta 2 this way. That's your final answer. So basically it is a head-on plus simply two perpendicular components. If you just remove the perpendicular components, it's a head-on collision. And that you know how to do. Have a look at this process. So that's what I was saying. If your head-on is good, head-on oblique is not much.
So can you go back for a minute? Yes, so thank you.
Clear? Let's see a question on this. You guys try using this. This is the top view. Let's say you're playing caroms. So we have a coin here, mass m, radius r. So we have a striker here. This is going with speed u, where the velocity is just a tangent to it. Matlab, indirectly this distance is given as r. This is also mass m and radius r, and e is equal to 1. This is a simple one. Find the velocities after collision.
ऊपर वाला रेस्ट में सर
Come again?
ऊपर वाला रेस्ट में
Initially this is at rest.
So can you go to the previous page for a second? Yes, sir. Thank you.
Okay, let's see. We have one answer. Let's see. Others try. I'll give a minute more, then I'll show you. What is step 1? Draw the normal when they're about to collide. So when they're about to collide, if you draw, this is 2r. No, I didn't draw it properly. This is r. This would be 30 degrees. So if this was u, this component will be u cos 30 and this component will be u sin 30. So you can split this into two parts. Velocities along the normal plus velocities perpendicular to the normals. So this would be u cos 30. This is at rest. This would be u sin 30. These components are unaffected. And we know if two balls of same mass collide, what will happen? This is mass m, the exchange velocities. So this is what I was saying. Velocities will exchange only along the normal. Complete velocity exchange nahi hoga. So there will be a statement question. If two bodies of same mass collide elastically, the velocities will exchange. It is wrong. The exchange velocities only along the normal. So in this case, it would be, so this guy will come to rest. This guy will go with u cos 30. This will come to rest. Plus, this is already at rest, perpendicular components. And this guy will go with u sin 30. So your final answer will look like this. This goes this way with u root 3 by 2. This guy goes this way, perpendicular u by 2. They both actually fly off perpendicularly. So if two masses collide obliquely and d is equal to 1, they fly off perpendicular to each other. That could be again a question. If two bodies of same mass collide elastically, after collision, they will move perpendicular to each other. Is it necessary? Not necessary. If one of them is at rest. If one of them is at rest, then they'll go perpendicularly. The other guy is going, there's no guarantee. Check it out. Idea is clear? Check it out. I'll give you one more like this now. You try. So that's it. If you see, oblique is simply resolving the components and solving a head-on collision problem. Let's say we have a coin here, mass m, radius r. We have another striker here, let's say 3m and r. This is speed u. This is going like this. This is the center. So from center to here, this distance is root 3r. And let's say E is equal to half. Find final velocities. U by 8, 11 U by God, you got greater than U. Did you observe? Coin ka speed is U. After collision, you got speed greater than U. You have created more energy out of less energy. We need you for the future. If someone can create more energy, you are the next Bill Gates or Elon Musk. U root 3 by 2 U bet. First thing, angles. It's always the angles, the geometry. So when they're about to collide, this is 2r. Now this won't touch here. This is root 3r. So this angle is 60 degrees. So this is U. This would be U cos 60 and this would be U sin 60. So you can split this into two parts. This guy is going with U by 2, 3m, m, and E is equal to half plus m, 3m, and this is going with U root 3 by 2. This is unaffected. This thing you can just throw it outside for now. This is at rest. So after collision, let this velocity be v1. Let this velocity be v2. Conservation of momentum, quotient restitution. 3m u by 2 is equal to mv1 plus 3m v2. 3u by 2 is equal to v1 plus 3v2. Coefficient of restitution v2 minus v1 by, here u1 is 3m, 0 minus u by 2 is equal to half. I took this would be your u1 and this would be your u2. I wrote reverse. This would be your u2 and this would be your u1. E2 minus u1 by u1 minus u2 is equal to half. So v2 minus v1 is equal to minus u by 2. This is your equation 2. Take v2 from here. Actually, add them directly. Add here to v1 will cancel. You end up with 4v2. 4v2 u. So v2 is u by 4. Think so. That's right. Then V1 will be 3u by 4. Am I right? Hi, u by 4, I goofed up. And how much will this be? Even the 4v2, 3u by 2 minus u by 4, 5u by 4, 5u by 16? No, let me solve actually. v2, v1, 4v2, 3u by 2 minus u by 4, 6u, तो ये 5u by 4 by 4, हाँ 5u by 16 आ रहा है, am I right? v1 भी आ जाएगा यहाँ से, या v1 भी कैलकुलेट कर लेना. So for this is at rest, and this guy is going with u root 3 by 2. So your final answer will be m will go with v1. This 3m will go this way with u root 3 by 2, and it will go this way with v2. So it will go up at some angle. Check out the steps. So oblique is really not that different,
फिर
but
मुझे
to check the steps.
13u by 8 ही आ रहा है.
13u by 8.
पता नहीं वो greater than 1 क्यों आ रहा है, but आ रहा है.
Maybe you forgot this minus sign नहीं है क्या? Maybe you forgot the sign here, goofed up somewhere. Check करो, 13 का chance ही नहीं है ना. You also know that. So that means you guys are doing some common mistake. Somewhere you are goofing up.
फिर वो जो minus u by 2 है नीचे.
Be careful ना, v2 minus v1 and u1 minus u2. Who is your 1 and who is your 2? Define properly. You can take anyone as 1 and anyone as 2.
अच्छा, उसमें मैंने minus sign करा, मतलब
हाँ,
ये
I think ये v2 ये u2 लेना चाहिए. You must have taken that is 1. वो goof up हो गया होगा.
हाँ.
Yeah. You must, meaning यहाँ पे तो u by 2 minus 0 ले लिया ऐसा.
Yes sir.
All got this? There. I'll give you a homework question. Try this and come. So Friday when we meet, we will do this. We have a floor here, smooth. Restitution is E. We have a ball here with speed U. Hits the floor and bounces off. This is theta. This is phi. And after collision, the speed is V. Ball collides with a floor. With speed U at angle theta. Bounces off with speed V and angle phi. The first one is fine. ये तो standard question है ये part. E and mu. Ground is rough also now. This is theta. This is phi. This is V. Find V and phi. Second one is a good one. Second one is a good advanced question. The first one is a standard one. You will see that in bits, CET means. Second is a good one. What happens if there's a friction on the floor and you're hitting at an angle theta? Try this. So Friday, first thing we meet, we're going to discuss this, and then we'll continue with few more oblique collision problems. And then we'll start off with variable mass system also, rocket propulsion and all that stuff. Maximum we should be able to finish off next class. Maybe little whatever left over that will be done next week. After that, we'll start off with rotational mechanics. So do make sure to go through the entire notes. We have done almost 48 problems. You'll be able to handle most of the problems now. Do finish your classes ka booklet. Don't wait for it because suddenly major test aa jayega, you won't have time to solve. And they will drag the portion to the last and they will rush and I don't know what they'll do. So do start solving. Don't wait for the chapter to get over. It'll be too late then. Okay, so with this we'll wrap up for the day. So the test is online till Thursday, night 11 o'clock. So do make sure to give it. Okay, so with this we'll wrap up for the day. So any doubts, anything, stay back and ask, or else you're free to leave.
So can you show the 46th one?